Hey everyone, welcome back to my channel EduVibe. In today's lesson, we are doing the topic of the electromagnetic radiations of grade 12 physics, which is Snell's law. So this is a law which is very important. This is a continuity of the refraction topic which we did in the previous lesson. If you didn't watch this, watch that first, then move on to this lesson. This is the important lesson, important law, and important formula which is easy to do. So, what is Snell's law? So, refraction had been observed for the centuries, but it was not until 1621 when the mathematical relationship involving the refraction was devised by the Dutch mathematician, the World War Snell. So, this will give the relationship between the angles. This will give the relationship between the index of reflection with a more like a theory part, like a more like a very stretched part, and they get the law from that. So Snell did identify the relationship between the angle of incidence and the angle of refraction as follows. So as we will say that in the first medium you will get the incident ray and the reflected ray. Then on the another medium you have a refracted ray. So index of refraction is in that medium and angle of refraction is at the another medium. So they give the relationship between both. That uh, they will get the relationship that sine theta, which is your I, and sine theta r, that r should be your angle of refraction. This both should be the constant. If we divide this, we get the constant thing, that both should be the constant. And then it turns out this constant is just for the ratio of index for the refraction between the refracted and the incident media. For generally the ratio takes the following form. So with the following form they take, that now this theta I, sine theta I and sine theta r will give you this thing, which is the refraction between the refracted and the incident medium. That index of refraction of the reflected medium, the index of refraction of the uh, incident medium. So they will get the two things, that sine theta I upon sine theta r is equal to nr upon ni. We are not generally work with the I or R because R is always also for the reflected. So we turn it out as a 1 or 2. So instead of using the I or R, we use the 1 or 2. We use the whichever method you prefer, but we write the above equation as. So if in 1 and 2, so that I turns out with 1 and R turns out with 2. So we get the first formula from here of the Snell's law. But this is the like not a like this formula. We will do some cross multiplication to get the more like a nice view of this formula. We do n1 times sine theta 1, then n2 times sine theta 2. So this will formula you will see. You want, like, if you want sine theta 1, so you can isolate the whole thing and get the sine theta 1. So you'll get this by your like convenience, what thing we want to do. So you will get n1 is the index of refraction of the incident medium. They have no units. N2 is the index of refraction of the reflected medium, no units. Theta 1 is the angle of incidence related to a normal line in degrees. This is the angle of reflection related to a normal line in degrees. And this above equation is all known as the Snell's law. So from here you get this Snell's law, and this is the important law. You use this formula frequently, and you will add something new in this too. This is the formula first, that for the Snell's law, and there is another formula which is that. So from where we get this formula, this is not your thinking that we don't want this, that where this formula made, but you have to know this, that this is another formula. When you have a any relation between the velocity, wavelength, all the index of reflection, you will get this formula. This formula is taken from like this formula. The formula in the first lesson, V is equal to frequency times wavelength. And with the further advancement in the Snell's law, you will get to know about this thing. You will get to the, when you do the higher studies, you will get to know how this formula made. This is a very important formula for Snell's law again, because when we get anything from the, if you want the wavelength one, if you want the n1 one, so you can do anything with that formula, because this all equal to the all the things in this, because all three are equal to. N2 and 1 remains the same. V1 is the speed of light in incident medium. V2 is the speed of light in reflected medium. Wavelength is the light in the incident medium. This is the wavelength of light in the reflected medium. These both are in meters, these are both in the meter per second, and they have not units. So that all two formulas we use when we doing the calculation questions in that thing. So let's start with this. So this is a long question and we will learn about all the things in this now. Okay, the light of wavelength 737 nanometers enters the contact glass, which has a 1.47 from the air with an angle of incidence of the 32.7 degrees Celsius related to the normal. In the contact glass determines the light rays angle of refraction, speed, wavelength, and the frequency. So here's the first medium is air, because from the air this enters the glass from the air. So first is air, and second medium is your glass. So that's two mediums we have, and we also have the n1 and n2 in this. So I have to find all the variables we have to given. So this is your n2 means. So n1 is air. Air has also 1.00. N2 has 1.47. We also have something else too. Wavelength 1 we have was light of wavelength of this enters to the glass, which means that air has this wavelength, which is 737 nanometers. Wavelength 2 you don't have, you have to find over there. Then we have thetas. So theta 1 you have. So in the incidence is this. So this is theta 1, 32.7. Here we have to find over there, which is angle of refraction. Then V1. What is V1? So they mentioned that from the air they mentioned. So from in the air you have a speed of light in a vacuum. In the first medium you have in vacuum. So this is equal to the C, where C is equal to this 3.0 to 10 raised to power 8 meter per second. V2 don't have. That V2 you have to again find. And one extra last thing you have to find, which is the frequency. So four things you have to find in this question, and this covers all the concepts of this. So let's focus on the angle of refraction with the angles. So firstly, do with the A. So we have to find the angle of reflection. So we have n2 upon n1. So we use that thing with equal to the sine theta 1, which is a Snell's law. This is equal to this. Do the cross multiplication. And you have to find the sine theta 2 and n1 sine theta 1 is equal to n2. So sine theta 2, make sure when you do this question with the sine, you have to be in your degree mode, otherwise you get the wrong answers. And this one is 1.47. So sine theta 2 is equal to, you get 0.36751 something, and theta 2 is equal to the reverse. You already done this reversing, reverse trigonometry in math. So you will get this. That theta 2 you will get about 21.6, your 3 seconds. So this is your theta 2 angle of refresh. Now for B part, you have to find the speed. So you have to find the V2. Now you use the relationship of n2y and n1 is equal to the V1 upon V2. Because you have V1, you have to find the V2. So same thing, n2 upon n1, which is equal to V1 upon V2. N2 V2 is equal to n1 V1. So that V2 is equal to n1 V1 upon n2. N1 is again 1.00. V1 is 3.00 10 raised to power 8 meter per second. This whole thing equal to 1 point divided by 1.47, and you will get V2 about 2.040 into 10 raised to power 8 meter per second, and you get V2 about 3 this 2.04 into 10 raised to power 8 meter per second. So this is a V2 now, speed of the glass in the other medium. So this is a B. Now for C. For C, you have to find the wavelength. So you again use n2 upon n1 with the wavelength. Now, So n2 upon n1 is equal to wavelength 1 upon wavelength 2. So n2 wavelength 2 is equal to n1 wavelength 1. So wavelength 2 is equal to n1 wavelength 1 upon n2. N1 is 1.00. This is 737 nanometers. Why use nanometers? Because it didn't mention anything. So in nanometers, you get like a nice answer. If you want, you can do. You get the long answer, but this is like the same answer you get. But this one is also right because the wavelength one is in nanometers. So I take this also in nanometers. That's why I do just thing, not like anything else. So this is 1.47. You will get this about 501.36 nanometers, which is 501 nanometers. So this is your wavelength 2. For last one, you have to find the frequency now. So you have all the things, but you have to use for only the twos then, like V1, V2, that all twos thing you have to use. So frequencies has to be used. So V is equal to frequency times wavelength. Frequency is equal to V upon wavelength. So when you use the wave velocity and the wavelength, make sure that both you use this from the same medium, not like you use the V2 and then you use the wavelength one. So they should be from the same medium, either from the first medium, either from the second medium. I will do this by the air because air is easy. So I do with the V of the air upon wavelength of the air. You can also do it by the glass if you want. Okay. So this is equal to, we have speed of 3.00 10 raised to power 8 meter per second, 737. Now you have to convert nanometer into 10 raised to minus 9 meters. This is a frequency. And when you find it out, you will get 4.0736 this 10 raised to power 14 hertz. So this is the frequency. So all what you do with just that 4 answers, and you will get about like 4 to 5 marks from these questions to get the your right answer. So that's all for this, and you will now know about the Snell's law again. And this will end by the this will also end the part 1 of this unit. And the next lesson we do the practice question of that part, and then we move on to the second part. So yeah, learning with EduVibe, learn smart, not harder. Please like, share, and subscribe to my channel. If you have any questions, let me in the comment section. See you in the next lesson. Till let's get it with EduVibe.